smart civil engineers. I'm Engineer Masroor and you are watching Engineering Network YouTube channel. Welcome to class number 8 of Surveying and Leveling course. So in this video lecture, I'm gonna solve another numerical question using line of collimation method. And also it is called height of instrument method as well. So in this video, I'm going to show you that how to calculate reduced level of different stations in road survey with the help of line of collimation or height of instrument method. So please watch this video completely, and if you want to become a successful surveyor, then please follow surveying and leveling course on my YouTube channel. Before that, if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button and also make sure to press the bell icon for more civil engineering videos. So let's start. Okay, so the question states that a road survey is taken with the dumpy level and following readings were taken. The instrument is shifted at 4th and 7th reading, and the reduced level of benchmark is 550.486 meter. Calculate the reduced level at different station points and perform usual checks. Also find out the difference between reduced level of last station point and reduced level of first station point. So this is a simple numerical question. Now in order to solve this numerical question, first let me draw line of collimation table. Here in this table, first column will be the station, second column is backside, third column is interside, fourth column is foresight, fifth column is height of instrument or HI, sixth column is reduced level, and seventh column is remarks. Okay? Now in the station column, I will write these numbers. Now actually these numbers are the station points, which means that in this road survey, I have taken 8 station points, right? Now remember that the first reading will always be the backside and last reading will always be the foresight, right? So here the first reading is 0.456, which is the backside. And the last reading is the foresight, which is 3.71. Okay? And here I will write BM, which stands for benchmark. Now in the statement of this numerical question, it is given that the instrument is shifted after 4th and 7th reading, which means that there are some kind of abstraction in the road survey line, right? So I will take 4th and 7th reading is the foresight, which is 1.751 and 2.421, and 5th and 8th reading is the backside, which is 1.128 and 0.926. Okay, so let me write the readings of foresight and backside at their respective stations. Now the remaining readings are the interside. So let me write all the remaining readings in the interside column. So this is the data that is given to us in the numerical question. And now I will use line of collimation method in order to solve this question. So at station 1, the reduced level is 550.486 meter, which is actually the benchmark for the instrument. Okay? So here I will write 550.486. Now at station 1, I will find out height of instrument, which is also called HI. So the HI formula is reduced level plus backside. And height of instrument at station 1 is equal to 550.486 plus 0.456. And the height of instrument at station 1 will become 550.942 meter. Okay? Now I will use this height of instrument in order to calculate the reduced level at remaining station points. So at station 2, reduced level is equal to HI minus interside of station 2, which is equal to 550.942 minus 0.721, and reduced level at station 2 will become 550.221. At station 3, reduced level is equal to 550.942 minus 0.582, and reduced level at station 3 will become 550.36. At station 4, reduced level is equal to 550.942 minus 1.751, and reduced level at station 4 will become 549.191 meter. Now in the question, it is stated that the instrument is shifted at 4-3 okay, which means that at station 4 I will again calculate height of instrument. So HI is equal to reduced level at station 4, which is 549.191, plus backside at station 4, which is 1.128, and height of instrument RHI at station 4 will become 550.319. Okay, at station 5, reduced level is equal to 550.319 minus 1.362, and reduced level at station 5 will become 548.95. And similarly, I will calculate reduced level at the remaining stations. Okay, so let me directly write all the reduced level at the remaining station points. So this is the complete line of collimation or height of instrument table. And if you want to work as a surveyor, then you will get this type of table and you will be asked to fill it on the side. Okay. Now also it is required that I have to do a check in order to verify the results that I have got. Okay. So the check states that sum of backside minus sum of foresight must be equal to reduced level at last station minus reduced level at first station. Okay, here the sum of backside is equal to 2.51 and sum of foresight is equal to 7.882. Reduced level at last station is equal to 545.114 and reduced level at first station is equal to 550.486, right? So 2.51 minus 7.882 must be equal to 545.114 minus 550.486. And after calculations, I have got exactly same result at both sides, which is minus 5.372, which indicates that our result is totally correct, right? So this is all about line of collimation method or height of instrument method. Now if you want to learn about rise and fall method, then please check out my surveying and leveling course. Also, if you have any confusion, then let me know in the comment section. If you find this video informative, then please like this video, share it with your friends. And if you are new to my channel, then please click on the subscribe button and also make sure to press the bell icon for more civil engineering videos. See you in the next video.